Pod Disruption Budgets, PDBs, have become a crucial tool for ensuring application availability and resilience in Kubernetes deployments across various industries. Here are some real-world examples illustrating their diverse applications. 1. E-commerce platform. Scenario: a high-traffic e-commerce website relies on microservices architecture deployed on Kubernetes. Challenge: maintaining high availability during peak shopping seasons and software updates. Solution: implement PDBs with min available set to a specific number of replicas for critical services like cart management and order processing. This ensures smooth operation even during node upgrades or scaling operations. 2. Financial services company. Scenario: a financial institution utilizes Kubernetes for trading platforms and other critical services. Challenge: downtime can lead to significant financial losses. Solution: designate PDBs with min available. 1 for core services like trading engines, guaranteeing at least one instance remains operational despite disruptions. Additional PDBs with max unavailable. 1 might be used for non-critical services like reporting tools, allowing controlled maintenance without impacting core functionality. 3. Telecommunications provider. Scenario: a telecom operator relies on Kubernetes for critical network infrastructure management. Challenge: downtime in network management services can disrupt communication across the network. Solution: implement PDBs with strict min available settings for services responsible for routing and traffic management. This ensures uninterrupted service even during node maintenance or scaling operations. 4. Healthcare organization. Scenario: a hospital utilizes Kubernetes for electronic health record (EHR) systems and other patient-facing applications. Challenge: downtime in EHR systems can have severe consequences for patient care. Solution: configure PDBs with min available. 1 for critical services like patient data access and medication management. This guarantees uninterrupted access to vital patient information even during infrastructure updates. 5. SaaS platform. Scenario: a software as a service (SaaS) provider uses Kubernetes for their core application infrastructure. Challenge: maintaining high availability and minimizing downtime for paying customers. Solution: employ PDBs with dynamic min available based on the current number of replicas. This ensures sufficient capacity during peak usage while allowing controlled maintenance during off-peak hours. Remember, these are just a few examples, and the specific application of PDBs will vary depending on your unique infrastructure and needs. However, they effectively demonstrate the versatility and value of PDBs in ensuring the availability and resilience of mission-critical applications across diverse industries.